Hello, welcome to ZTalk. If you watch my previous session about infrastructure as code, I talk about the concept, and more importantly, I compared those most popular infrastructure as code tools in the market and how those different tools work together as an enterprise solution in the real world. Here is the link if you want to jump over there to take a look. I think it will be helpful one way or another if you want to learn more about the tool set in detail to practice infrastructure code in your environment and to understand more what does each set of tools do or each set of tools good at. All right. We have been learning Terraform together, meanwhile, which is one of the most popular tools for infrastructure automation, right? And I also had a couple of demo sessions about Ansible, which is another hot one for configuration automation specifically, right? In this session, let's talk about the build automation tools solution, Packer. Um, Packer is another open source tool for creating identical machine images for multiple platforms from a single source configuration. It automates the creation of any type of machine images, even including Docker images. A machine image that Packer creates is a single static unit that contains a pre-configured operating system with installed software, which can be pushed by Chef, Ansible, the configuration automation tools, right, on top of it. For example, we wanted a predefined Nginx installed on CentOS. So let's take a look at this equation. Packer equals pre-configured OS plus configuration. So in this use case, CentOS 7 will be the pre-configured operating system image, and Nginx will be the software package that needs to be installed on the CentOS 7 operating system. With Packer, you do not have to spin up a EC2 instance on AWS, for example, with CentOS operating system, and then install software after instance is up and running again, like we previously did in our Terraform session. Instead, you just needed to install the Packer image. Basically, that's immutable infrastructure all about, right? Every time we have a new code release, for example, or any configuration change required, we rebuild the image via Packer and spin up a new instance with this new image that was just built, rather than updating the change on top of the existing environment to avoid configuration drift. Now let's understand how does Packer build image. Basically, Packer combines machine image plus JSON. Apparently, machine image is the operating system that you want to install. Let's say CentOS, Ubuntu, Red Hat, Windows, whatever. And JSON means the Packer template, where you need to define what the configuration looks like on your machine. Once it's all done, you just run the Packer command. Packer will then spin up a temporary computing instance on the cloud provider like AWS EC2 or Azure or GCP. The OS you wanted with the configuration you defined will be hosted on this temporary instance so that Packer confirms everything is good, and it will build a new machine image based on that afterward. Now let's review a couple of key Packer terminologies. Template. template is the configuration file that is used to define what image we want to build and other configurations on top of the operating system. Builders are responsible for creating machines and generating images from them for various platforms. There are separate builders for each cloud provider, each with its own configuration. Let's say AWS its own builder, Azure has its own builder, something like that. Provisioners are used to install and configure the machine image after booting. They prepare the system for use by installing the required packages. All right, demo time is my favorite time. All right, so in this demo, I'm gonna build a custom AMI by Packer. If you remember, I was using the remote exec provisioner to install Nginx via a shell script in my, I think, first Terraform session after the EC2 instance was spin up, right? With Packer, we do not have to do that anymore. We could build our own custom AMI, which contains pre-configured Nginx. Imagine in the real world, there must be a bunch of heavy softwares on our machine to provide the business services, right? This way will speed up the boot time of the machine dramatically, as we do not have to execute anything at runtime. Also, this will be helpful to create the cluster services because we can use the same image we built or we customize across the board, right? Cool. Let's jump to the demo. But before I'm doing that, remember to thumb up my video if you think it's helpful, and subscribe my channel if you haven't done so. And most importantly, again, leave comments if you have any questions. All right? Cool. All right, first thing first, we will need to install Packer CLI on our laptop or the machine where we run Terraform. All right, so just Google Packer download, and here we go, the first link to the official website. Based on your flavor, just follow the instructions to install Packer CLI. All right. Again, I'm using Mac OS, so always homebrew is the first choice. So just follow these simple commands right here. Install Packer. So once Packer is in place, just go to your command line and run Packer version to verify Packer is installed successfully on your laptop. All right. Cool. Once Packer CLI is in place, we're good to move forward. So before we start build stuff, let's understand the workflow. So firstly, once you finish up the Packer template, you execute Packer validation to verify all the configuration that you did was good. Then you execute Packer build. Packer will take care of the rest based on the configuration in the template. Once that is done, Packer will save the artifacts in the destination. Here, the artifact means the machine image. Then we can instruct Terraform to spin new instance with the new machine image we just built. Being said of that, we understand the workflow. Let's start with template. I'm gonna use the Nginx example that I brought up in the presentation. It's pretty simple. If you remember, I was using in the previous Terraform session, I was using Nginx, a shell script to install Nginx, right? I'm gonna do the same thing here. So here, case one, I just created a folder called case one. Inside of this folder, it contains a case1.json. Basically, that's the template file, the Packer template file. It's JSON formats. And another one is the shell script for installing Nginx. It's pretty easy. Just just run apt-get update and then install Nginx. So back to the template. Here is the framework of the template. The first section will be the variable where you need to give your AWS access key, secret key. So here you need to put your own access key security accordingly here. After that is the main section at builder. So as you can see, the builder is the type is the Amazon EBS, and I'm calling the variable AWS access key, secret key that I defined above right here, right? And you define a region where you wanna spin up the instance, and source AMI filter. Basically, this is the base OS. Here I'm using Ubuntu v16. So you might ask, where did I find these base AMI? So here, there is the documentation on the Amazon website. Find a Linux AMI. Just read it through. So basically, you can find an AMI using AWS CLI or using Portal. Either way, just take a look these documentation. I'll share this in the description of this video. All right. Back to Visual Studio Code. Let's move down, and you can see the instance type gonna be T2 micro. And the SSH username, as always, we use Ubuntu as the username, SSH username. And the new AMI name, so we need to give a name of the new custom AMI, right? So I'll call it case one hyphen Packer hyphen. We give a timestamp here, so we know which specifically these image all about. All right, so the last section is called provisioner. Basically, it's just called that shell script we created over here for installing Nginx on top of the Ubuntu operating system. That's pretty much it. So let's save it and jump to the command line. I remember that workflow. We need, once we finish up our templates, we need to validate if the templates syntax or if the templates is okay. So by that Packer command, Packer validates, right? So let's go to our command line. Just issue Packer validate, and we need to validate these templates. Hit enter. All right, no error returned. So, which means these templates looks good. We can run Packer build to build the or image based on these configuration. We passed the Packer validation. Let's run Packer build to see how it goes. Packer build case one JSON. Hit enter. All right, as you can see here, it says font image ID. So it's gonna spin up a temp. Remember the workflow is gonna spin up a temporary image and install the the OS based on these base AMI, and then install the Nginx via that shell script. Let's go to AWS console and see how it goes. Let's go to EC2 instance. There should be a temporary instance. You see here, the instance showing name is Packer Builder. It's still initializing, so let's give it a little bit of time. Back to the console. All right, looks good, and you can see it's using SSH to is using here is running that Nginx shell script to install Nginx, and here stop the instance. So everything looks good. It's stopping the instance. So let's refresh here, and you can see the Packer Builder instance was stopped because it finished up the testing. Basically, in the temporary instance, it installed that base image, that Ubuntu image, and then it successfully installed the Nginx on top of it. And then once it's done, it's gonna stop the temporary image like here, and then it's gonna create a new AMI. So let's jump back to the console, and you can see it's creating AMI. Remember, that's how we name the new AMI. So the case 1 -Packer -timestamp, right? So it's still creating the AMI. Here we go. So this is the AMI, custom AMI. So it's still waiting for AMI to become ready. So let's give it some time. It should be done in a minute or so. Okay, here we go. As you can see in the last 4 lines right here, the build was complete, and the artifacts of successful builds are, here is the AMI number. This is our first custom AMI. Next step, when we use these AMI in the Terraform, once the new EC2 instance spin up, we should have Nginx in place out of the box. So let's verify that. By the way, here is then another way to verify if your custom AMI was built successfully. So log on to your AWS console and go to the region where you build your custom AMI. And for me, it's the US was 1, right? And then go to EC2 instance, and you should be able to see a option under images. It said AMIs. So click that. So if everything works as expected, you should be able to see your custom AMI right here. So as you can see, this was mine. That was just built a minute ago, right? Okay, so now we've got the custom AMI ready. So let's finish up our demo. Let me explain the procedure. How does Terraform and Packer work together one more time, real quick. Okay, so firstly, we're gonna create a VPC. Once a VPC is done, we're gonna create a security group for that VPC. And lastly, we're gonna spin up the EC2 instance using the custom AMI that was just built by Packer. So basically, we can clearly see which part is taken care of by what tool. Like here, step 1, 2, 3, spin up a VPC, create a security group, and spin up EC2 instance. These deployment automation will be taken care of by Terraform, right? And regarding build automation, so how do we generate the custom AMI? That's going to be taken care of by Packer, right? Because this new EC2 instance going to be used the custom AMI that was built by Packer. All right. By the way, to review what we've learned about module in the last session, just to refresh your mind, so VPC and EC2 instance will be created by module. All right. So that's basically the plan. So let's work on it. All right. Here is the structure of combining Terraform and Packer together. If you see the left side of my Visual Studio Code, I create a new folder structure, and I'll explain how does Terraform and Packer work together as a bundle. As planned, I'm gonna restart the whole thing from the beginning. I'm gonna build a new AMI for Nginx running on Ubuntu, just like what we did just now, on another region via Packer. Let's say this time we're gonna build that AMI in US East 2 region. All right. And then I'm going to use Terraform to build a VPC security group and spin up a new EC2 instance using the new custom AMI on that region, that EC2, US East 2 region. All right, that's what we're going to do. Here, let's review the structure. So following the best practices, I break off modules to a separate folder. As you can see, besides deployment folder, I create another folder called modules. Basically, all the modules required for this project will be stored under this modules directory. As you can see, I only gonna need VPC module. So here we go. You can see there's another folder called VPC is stored under modules directory. And let's quick review. That's basically the same module we used in the previous session when we discussed about modules. So it's pretty simple. In the VPC.Terraform, basically I grab these module from the community, Terraform registry, and this is the source where I got this module. And down below is the configuration of the custom VPC. Right, so as you can see, I defined a couple of private subnets, a couple of public subnets, and in the output section, I gonna output the ID of these custom VPC out because I'm gonna grab the ID in the create instance, because the new EC2 instance will be hosted inside these custom VPC. All right, same thing. So the instance will be the EC2 instance will be running in on a subnet. So I'm gonna grab the one of the public subnet. As you can see, I'm gonna output all the subnets, and then I'm gonna show you how to grab these subnets shortly in the create instance .terraform file. All right, so finish up the modules. Let's jump to the deployment folder. So here, as I said, I'm gonna use Packer first to build a new custom AMI, right? So that's why I include the Packer template. We're gonna need that to build the custom AMI, right? So it's same thing like what we just tested just now in US West 1, right? So here I'm gonna use the same template, Packer template, to create to build the image for in the US East 2 region. Here we go. The rest is same, and we're gonna use the Ubuntu v16 as the base image, and I'm gonna call this. We're gonna able to SSH to that EC2 instance. As you can see, I defined the SSH username as Ubuntu, and the new custom AMI will be called custom-packer with a timestamp, right? And move to the provisioners section. As you remember, once the Ubuntu OS is up and running, we're gonna install Nginx on top of these operating system, and these Nginx will be bundled in the new custom AMI in the new image, right? So that's what we did. We're gonna use the shell command, shell script here, the installSoftware.sh script. I'm gonna install. Right, I'm gonna install Nginx was the package manager apt-get, right? Here, go back to the templates. Gonna use this script to install Nginx, and here as you can see, I'm gonna this execute command. I'm taking all the variables we defined here in this structure. I'm gonna take all those variables and set them as environmental variables in the path of a new custom AMI. All right, that's basically what this line means. Cool. That's the template. So let's validate if the template is good before we move forward to the next step. So here, let me go to this new folder. In their deployment folder, let's issue Packer validate and validate these templates. Here we go. Everything looks good. So the templates is good to go. So let's move to the next step for defining the Terraform. Here, as you can see, I create instance Terraform for spin up the new EC2 instance, right? So let's review from the beginning. So firstly, I include the module which is stored down here. So modules VPC, right? And then the provider is AWS. Again, you need to include your access key, secure key, and region, those information, right? And the key pairs. And here, as you can see, this is for SSH. And as you can see, I put my key, public key, private key right here. So I create a variable in the variables, variables that Terraform, the TF, for public key path, right? And back to the create instance, and here I'm going to create a security group, right? So I'll call these resource as allow SSH, and here we go. That's basically what I'm talking about, to grab the custom VPC ID from the module. Remember, in the modules VPC.Terraform, in the output section, I output the VPC ID, right, of my like here, right? So here, because the new EC2 instance will be hosted in these custom VPC, so here I'm gonna use this VPC ID right here. Develop VPC, my VPC ID, right? That's my VPC ID. That's the variable where I output the back to VPC, my VPC ID. Output the VPC ID of the custom VPC, right? Back to create instance.Terraform and move down, and I'll give the name of these VPCs, allow SSH and environment. And egress basically just open port 22, so we're able to SSH to this instance and give it a tag. Now, last but not least, I'm gonna define the instance, EC2 instance. And here again, this is how we're gonna use the custom AMI. As you can see here, I create a variable called AMI ID here. So that's these variable was defined in the variables that TF file here, and it by default is an empty string, right? So basically, once we run the Packer command to build the new custom AMI, you remember in the it will generate the AMI string. So we're gonna copy that string and pass that string as the argument when we run Terraform apply. That's basically what we're gonna do. And the instance type is another variable I defined right here, instance type, right? Back to create instance and subnet. That's the another output that was came from here, the VPC module, right? Output. We're gonna output the public subnets, right? And here is where in the deployment create instance, here is where I pick it up. So subnet, I'm gonna grab the public subnet because remember it's the list. I create 3 public subnets inside these custom VPC, right here. So I'm gonna host the new EC2 instance gonna be hosting in one of the public subnets. I picked the first one. As you can see, create instance.terraform. I picked the first one, right? And that's pretty much it. And the VPC security group, that's basically what I defined right here in the security group. Allow SSH, right? Allow SSH ID, right? That's basically the security group I defined right here. And I'm gonna use that security group, and that's pretty much it. All right, so let's jump to the console. So firstly, we're gonna build the we already run the validate of the Packer template, so we're going to build the custom VMI, right? So let's run Packer. Let's grab that file. So let me grab these template files. So let's run Packer build. So it's gonna take a couple of minutes to create the new custom AMI. Let's watch it through. All right, it's connected to SSH. And it's running provisioner. As you can see, the AMI is already found the base AMI, which is the Ubuntu V version 16, right? So the base OS has been installed and is connected to SH, and then it moved to the provisioner section. Basically, in the provisioning section, it's gonna run that shell script to install. Here we go. That script right here. You're gonna run this shell script to install Nginx, right? So move along. All right. So as you can see, the Nginx was installed successfully, and it's stopping the source instance. So let's double check on the EC2 instance on the AWS console. So I'm on US East 2 region, and let's check the instance. There should be one for Packer Builder, right? These were the one, and as you can see, it's stopped, right? Because it's already done. So it's creating the new AMI. let's wait for AMI to become ready so we can grab that AMI string and move to the Terraform step. Basically, we're gonna pass that AMI as a argument when we issue Terraform apply. I'll show you shortly. Alright, it's done. As you can see, the new custom AMI was built successfully. This is the AMI string. Let's copy that and put it in my note here, and let's also double check on the console. So click AMIs and you can see this is the new AMI we just built out, right? Custom Packer and timestamp. Alright, so we got the AMI, so the Packer has finished his job, then move to Terraform. So on the Terraform side, what we need to do, we need to run Terraform init first, so Terraform can download that modules, right? And then once the initialization is done, we're good to issue Terraform apply. So I just copy that. Here we go. Here I include the AMI ID right here, and also I put in the my access key and secret key as a argument. So this is the command. Let's issue Terraform apply to see how it goes. All right, so looks good. Let's type in yes to apply. And as you can see, there will be 22 resources being built, and let's give it a couple of minutes to create the VPC, the security group, and spin up the new EC2 instance. So let's jump to the console, and here click instance. You can see here there is the new instance is showing instance state is pending, and let's see VPC. All right, as you can see, this is the custom VPC, and let's go inside of this VPC. You can see that's exactly the VPC we defined, right? And the environment, I called it the talk demo. That's exactly what I did here in the variables.tf. See here, the environment is ZZTalk_demo. All right, so cool. And let's go to the subnets, and you can see there are a bunch of public subnets and private subnets inside this custom VPC. All right, and everything looks good. Let's double check on the command line. All right, as you can see, the apply complete. There were 22 resources being added, and let's verify. Go to your go to EC2 instance. Here we go. There is the running instance. This is one using the new custom VMI, right? Let's verify that by SSH login to this instance to see if the Nginx was in place already, right? So here is how we're gonna log in. So back to the let's run SSH. Was the public IP, because these EC2 instance is hosted in a public subnet. So I'm going to use this public IP to get access. The username is ubuntu, and gonna include the private key, which is this guy. Hit enter. All right, I'm in. So let's run that apt. What's that command? Apt list installed. Let's grab Nginx to see if this is installed. All right, as you can see, the Nginx was installed right here. Right, so we can do a curl localhost. Here we go. Welcome to Nginx. So that's pretty much what I want to show in this session, to see how do we use combine or bundle Terraform. How does Terraform and Packer work together as a enterprise solution. All right. Good. Let's call it a day. Thanks for watching, and I will see you next time. Alright, thank you for watching my video. If you think this video is helpful, you're more than welcome to leave any comments. Remember, thumb up, subscribe my video, and also hit the notification bell. See you next time.